Now we attempt this problem, this problem 59 of your textbook. It says a uniform rod of mass M and length L is stuck at an end by a force F perpendicular to it, perpendicular to the rod for a short time interval T. Now, as I said earlier, this phrase that for a short time interval T, yes, that this is a problem of impact of the force. Because, you know, the impact is called that when a force acts on a body for a very short time interval. So, if we go to the problem, what do you find? That, that there is a stick of length L, the stick of length L, and it has got a mass M. It's struck at the end by a force F. Say this stick is at this end, it is struck by a force F for a short time interval small t. Calculate such and such, such and such. That now, before trying to calculate anything, let us see what will happen. You can try it. You can try it at your home. That if you put a pencil like this on your study table, and then if you knock at one end of the pencil, watch what happens. Now, since a force has been applied on the pencil, if we go by the basic kinematics, the force will create a linear translation. Will the pencil move like this? That means from here to here? Of course, our common sense says no. Then, will the pencil rotate like this, taking its center at the axis? Our common sense says no. You can try it at your home. What will happen really? The pencil will have both translatory and rotating motion. That means new position of the pencil may be something like this. That means it will move as well as it will rotate. So here also, this pencil will move as well as it will rotate. Now, what are the questions? Questions are, calculate the speed of the center of mass. That means at what linear speed the center of mass is moving. If we want to calculate this, part A, as I said, this is a problem of impulse force. Now, impulse is measured by, we normally call it F del t, but here time is given t, so impulse is ft. So impulse is ft. Also, you should remember from your kinematics session, also, impulse is always equal to change in the momentum. Normally, we call it impulse is equal to del p. You can also call it p minus p naught. That means new momentum minus original momentum. If it is already having a momentum, or if it was initially at rest, then of course impulse is equal to the new momentum. Now here the pencil was at rest, so the momentum of the pencil. Now pencil, now they have called it a rod. Momentum of the rod is by definition, momentum of the rod is equal to impulse. Let me write everything so that you don't forget it. Momentum is equal to impulse is equal to Ft. And also momentum is equal to, also we know momentum is equal to P equal to mv. That means mass into velocity. So in this case, they wanted us to find out the velocity. V is equal to momentum divided by m, and momentum is equal to impulse. So V is equal to Ft by m. This is the answer for you. See, look, the deduction or the problem is very, very simple, but only you have to understand the problem and attack the problem in the right direction. Then secondly, the angular speed of the rod about the center of mass, right? Now, as I said, the rod will move linearly. Also, it will it will have an angular move. Now, what is the angular momentum? By definition, if you go to solve the part D, angular momentum L is equal to, I omega. I is the moment of inertia, right? And also, how we measure angular momentum? Also, angular momentum L is equal to the linear momentum, linear moment multiplied by the R. That means this moment which is applied here, that multiplied by R. R is the distance from the center of rotation. That is the definition of the angular moment. So, here R is equal to L by 2, length of the rod divided by 2, multiplied by linear momentum T, where P has been already found in part A, P is equal to Ft. So this is L Ft by 2. That means I omega equal to Lft by 2. So I omega is equal to Lft by 2. That means from here we get omega. They want us to find out the omega. Omega equal to Lft by 2, that divided by I. 1 by I, the moment of inertia. Now, this is Lft by 2. Now, what is the moment of inertia of the rod which is rotating around its center? Is ml square by 12. So now it becomes 12 by ml square. If we do this, then this 2 and 12 makes 6. This L and L square makes only L. So the answer is 6Ft by ml. 6Ft T by ml. So this is the answer. Third, the kinetic energy of the rod. What is the kinetic energy of the rod? This is number C part we are doing. Now the rod has a translatory motion as well as a rotatory motion. So it has got two types of kinetic energy. One is a rotational kinetic energy, and another is a translational kinetic energy. Now, what is the rotational kinetic energy? Rotational kinetic energy is, we know, is equal to half m omega square, half I omega square, half moment of inertia I omega square. This is the rotational kinetic energy. That means this is equal to half I is ml square by 12, ml square by 12 into omega square. Omega, we have already found out 6ft by ml. So this is 6ft by ml whole square. This is equal to half multiplied by ml square by 2. Sorry, this is not ml square by 2. Extremely sorry, this is ml square by 12. ml square by 12 multiplied by 36 f square t square divided by m square L square. Now this L square gets cancelled. 12 and 36 leaves us a 3 here. And also this m and m square gets cancelled. We are left with only one m. So what we are left with finally? We are left with finally 3 by 2. This is equal to 3 by 2. 3 by 2 f square t square by m. F square t square by m. Fine. Now we have got rotational kinetic energy. What is the translational kinetic energy? Translational kinetic energy is, you know, is equal to half mv square. Half mv square. And here it is half m, half m. And what is v? We have v, we have found is ft by m. In part A, we have found. So this is ft by m whole square. This is equal to half m, or we write m by 2 into f square t square divided by m square. So this is equal to f square t square by 2m. So what is the total kinetic energy now? This energy plus this energy. So total kinetic energy is equal to 3 by 2 f square t square by m plus half f square t square by m. So this is, of course, is equal to 2 f square t square by m. So this is answer C. Now there is another small part, that is answer D. which wants us to find out. Sorry, the question has got upward. Question D, answer D was uh, angular momentum of the rod about the center of mass. Angular momentum is L, which is equal to I omega. This we all know, L equal to I omega. Answer D is L is equal to I omega. I we know ml square by 12. ml square by 12. Omega, we have already found out the value of omega 6 ft by ml here. So multiplied by 6 ft by ml. So this m and m gets cancelled. This L and L square gets cancelled. We are left with only one L. So this is equal to, and 6 gets cancelled to 12 by 2. So this is equal to F T L by 2. So these are the 4 answers. Okay. We now go to the next problem for you.